Go like this. I'm sorry, Miss Jackson. I am for real. Never meant to make your daughter cry. I apologize a trillion times. I'm sorry, Miss Jackson.
Hello and welcome to our fourth and final part of Chapter 7, The Integer Rules. Now we are going to get to some shout-outs. You will hear those in just a little bit. I'm going to start with the last part of our slide, which is just talking about dividing exponents. So, as we've seen in some of the other problems, I'm going to do this the long way, and then maybe perhaps we can look for a pattern and see if we can come up with a rule from this pattern, which, in case you forgot, goes back to our essential question from our notes. And yes, this should be added to your notes. This is the last part, all again talking about integers. So, let's say I want to simplify 8 or x to the 8th power over x to the 3rd power. And what does that look like? Well, x to the 8th would be 8 x's. So 1, 2, 3, 4, 5, 6, 7, 8. And because we're dividing, this is all going to be over x to the 3rd power, which would just be x times x times x. Now, if I want to simplify this, keep in mind that whenever you have x over x, any number over itself, assuming that x is not 0, of course, that it will equal 1, because any number divided by itself will give you 1. Or if we think of something that equals 1, multiplying by all this other stuff is not going to change anything because identity property, we can just do a quick wha and wha and wha. So you can practice your ninja skills with this section. So because the 3 x's that are in the numerator and denominator kind of cancel each other out, what are we left with? We are left with 1, 2, 3, 4, 5 x's. So if I were to write that, it's not 5x, it's x to the 5th power because we are multiplying it 5 times. So here's our final answer, x to the 5th. Now essentially what we're doing when we have this numerator over denominator is we're just subtracting out the ones that they have in common. So obviously we can come up with a rule if we are dividing a number with an exponent and they have the same base, we keep the base, subtract the exponents. 8 minus 3 gives us 5. Okay, let's move on to our next example. Now, we have a couple things going on here. I'm going to write this like this. X squared y to the 4th over x to the 5th y to the 3rd. Alright, keep each variable separate. So let's look at the x's first. We have the same base, so if we're dividing we can keep the same base. And then subtract the exponents. So we have 2 minus 5. This is where you have to be very, very careful with your integer rules. 2 minus 5 is not 3. 2 is smaller than 5, so when we subtract we get negative 3. And of course we're going to do something with that because you can't leave negative exponents in your final answer. And in this part we have y to the 4th over y to the 3rd. Keep the base. It's going to give us a y. Subtract the exponents. 4 minus 3 is 1. Okay, not quite our final answer because we have this negative exponent here. So don't forget what to do with this. This is like a warp zone. And our negative exponents move down because of the negative exponent warp zone. So we have x to the 3rd in the denominator. Of course, y has a positive exponent, so we just leave it the way it is. Don't have to write the 1. This is our most simplified form of our answer. Alright, so don't leave these with a negative exponent for your final answer. Alright, I'm going to hit pause, and you guys should hit pause too. We'll work on this problem. I will show you the answer, so I want you to try it on your own, done the same way for number 3 here. Alright, so I'm going to hit pause. You do the problem in your notes. Alright, so what you should have got in this problem is x to the third power. So why is that? If our bases are the same, they are both x, keep the base, subtract the exponent. So we have -1 minus -4. This is, like I said, where your integer rules have to be perfect. I advise you, if they are not, use a calculator. -1 minus -4 turns these two minuses into a plus. Signs are not the same. +4, -1. We subtract, take the sign of the bigger number. A +4 would give you bigger, so 4 minus 1 is 3, and it is positive, so it stays in the numerator. Now, if you got something different, rewind what I said, because I just went through those rules kind of quick, but this is the correct answer. Something to keep in mind is if you don't know whether the variable is going to end up in the numerator or denominator, looking at this problem. Say, go back here. We have a 2 and a 5. Where is the bigger number? 5 is the bigger number. So when we're all done with this x, that's where it's going to end up. It ends up wherever the bigger variable, the bigger number starts, where the bigger exponent starts. So since 5 is bigger than 2, the exponent with the bigger number, it ends up being in the same position. This was in the denominator, this is also in the denominator. So over here, between -1 and -4, -1 is bigger, that's why this ends up being a positive exponent, like you can think of it like the numerator. Okay, now how about, we'll do a shout out before I send you loose on the next problem. This is a shout out to happy early birthday for Cassie. Okay, not sure when your birthday is but happy birthday. And this one, kind of curious, this is just a shout out to Mimi the Kaz, maybe. You guys got to write your shout outs on a little bit neater, but Mimi the Kaz, or the cat, maybe. There's your shout out. Okay, so next problem to work on is our number 4 over here. Solve that one the same way we did number 2. Alright, I'm going to hit pause. We'll come back and work on some of those problems. Alright, so the answer that we should have got for our fourth problem is 1 over x. You can have to the first power or not. And y to the fourth, also in the denominator. So if you did not get that, keep in mind which one's bigger. Is it the 3 or the 4 for the variables for x? 4 is bigger. Final answer should end up in denominator because 4 is in the denominator. Which one's bigger, -5 or -1? -1 is bigger, so answer should end up in the denominator. -5 minus -1 is -4. When we send y to the -4th down, it goes in the denominator. Alright, so we also let's look at the next example. This one involves scientific notation. So we look for similar bases. I see 10 to the 3rd, 10 to the 6th. So if we are dividing that, we subtract 3 minus 6 is -3. So our base is going to have 10 to the -3rd power. And then we're dividing. 5 divided by 2 is 2.5. That's just straight division. So our answer is 2.5 times 10 to the -3rd in scientific notation. Turn that into standard form. We would just move the decimal 3 places to the left. 1, 2, 3. Final answer, 0. Make that decimal bigger. 0.025. Alright, so that's the third final answer. Alright, it's your turn on that third one. I want you to try it first, see if you can figure some stuff out. I will walk you through the final example, but I need you to try it on your own first. Ready? So hit pause and start. Alright, let's walk through this final problem. I tried to make some room so we could see it. Let's start with the easy part. Remember, this is division. So we have 12 divided by 4 is simply 3. Okay, that's the first part. Now look at the x's. We see the bigger numbers in the denominator, so we know x is going to be in the denominator. -1 minus 5 is -6. -6 is like a warp zone. Moves down. So we have x to the 6 in the bottom. Now look at the y. 6 minus -1. Minus the negative is like adding the bigger number here. Between 6 and -1 is 6. the 6 is in the denominator, or the numerator, sorry. And so that means in our final answer, y is going to be in the numerator with a power of 6 minus negative 1 is positive 7. Okay, last variable, z to the 5th. It's in the denominator, so our final answer is going to have z in the denominator. Negative 3 minus 5 is negative 8. Negative 8 is like warp zone, the negative exponent. Send it down where it will have the positive 8 as the exponent. Alright, and this is our final answer. If you did not get it, go back, try to listen to the last part. Alright, just as a quick summary for our exponent rules. If you're multiplying numbers with the same base, so this goes back to the previous section, multiplying numbers with the same base, keep the base and add the exponents. If you have a power taken to a power, generally seen with parentheses, keep the base and multiply the exponents. Sorry, I can't write as nice as you probably can in your notes. If you're dividing numbers with the same base, like we just did, keep the base and subtract the exponents. Beware of the coefficients, because coefficients have an exponent of 1. And you have to use that, especially in this rule here. You have to really be careful with coefficients. Alright? If you want to take some time, hit pause, go over these rules, write these rules down, whatever. They will help you in. Those are basically the 3 rules for the entire chapter. Oh yeah! Okay, this is our final slide, last part of the lesson. So like I said, or like it says here, do a learning check. Go back and look at some of your problems. Is there anything you need to know? This is the last section of your notes. So, of course, I would like you to summarize your notes. I will check these in class. And, oh yeah, I guess we do have some shout-outs to do. Shout-out to my favorite teachers. My homie Barnett, I guess that's me, and Miss Arbelize. Also have a shout-out to Carmel, a hardworking student. Yes, she is a hardworking student. And then our last shout-out, which, alright guys, I guess I should have told you, but shout-outs are supposed to be shout-outs, not essays. I know you're excited about FCAT right, but this last shout-out's a little bit long. Shout-out to Cherryberry for always asking questions about math homework to clear her confusion. That is true, she always does that. Shout-out to Brianna Wheeler for being my best friend from the beginning till now. Cherry loves you. That is sweet. Alright guys, good luck on the homework in Chapter 7. If there's anything you don't understand about exponents, go back and watch all 4 parts of this video. Have a good night.